What if you never had to charge your phone again? Welcome to the future of batteries, where the concept of the atomic battery is changing the game. This isn't your typical energy source. Instead, it uses nuclear power. Now, before you start imagining apocalyptic scenarios, let's clarify something. This technology isn't new. It's been powering space missions and submarines for years. Recently, a major battery manufacturer introduced a prototype of an atomic battery, a tiny powerhouse that can fuel smaller devices for up to 50 years without needing a recharge. Yes, you heard it right, 50 years. Imagine a small device, no larger than a coin, powering your smartphone, your laptop, or even your drone for 5 decades. Imagine a world without the need for computer and phone chargers. That's the promise of the atomic battery. In the next scene, we'll delve deeper into how atomic batteries stack up against traditional ones. Stay tuned. So how does an atomic battery stack up against traditional batteries? Well, let's dive right in. The atomic battery we're discussing today is the creation of Chinese manufacturer Betavolt. They've engineered a method to insert 63 nickel atomic isotopes into their new atomic battery dubbed the BV100. This tiny powerhouse is smaller than a coin, measuring a mere 15 by 15 by 5 millimeters. Despite its diminutive size, it can generate up to 100 microwatts at 3 volts. That's not just impressive, it's revolutionary. To put this in perspective, let's compare the atomic battery to a conventional lithium battery. The energy density of the atomic battery outshines its lithium counterpart by a whopping factor of 10. Yes, you heard it right, 10 times more powerful. That's akin to comparing the power of a horse to that of a high-speed train. The difference is that stark. Now you might be thinking, what can we do with such a small yet highly powerful battery? The answer is quite a lot. The compact size of the atomic battery makes it possible to connect several devices, for instance, in a mobile phone, thereby significantly increasing the effect. But the possibilities don't stop there. Consider drones, for example. With an atomic battery, a drone could potentially fly indefinitely without needing to recharge. Imagine the implications for aerial photography, surveying, emergency services, and more. It's a game changer in every sense of the word. So when we compare atomic batteries to traditional batteries, there's really no contest. The atomic battery's superior energy density, coupled with its small size and potential applications, makes it a clear winner. The future of batteries isn't just bright, it's atomic. In the battle of atomic batteries versus traditional batteries, it seems the future is atomic. This is not just an evolution in battery technology, but a revolution that could reshape the way we use and understand power in the future. But is an atomic battery safe and environmentally friendly? This is a question that naturally comes to mind when we talk about nuclear power. Let's delve into this. Nuclear power has been associated with a couple of concerns, the most common being radiation and waste. Yes, atomic batteries do involve nuclear elements, but here's where things get interesting. The atomic battery manufacturer has put forth strong assurances that these concerns have been thoroughly addressed in their design. The atomic battery uses nickel-63, a low-energy beta emitter. This means the radiation it releases doesn't even have enough energy to penetrate human skin, let alone cause harm. Furthermore, the battery is encased in a protective shell that effectively blocks this minimal radiation. So, rest assured, carrying an atomic battery in your pocket won't turn you into a superhero, or a supervillain for that matter. Now, let's talk about waste. Traditional batteries, especially lithium ones, pose significant environmental risks. They are difficult to recycle and often end up in landfills, leaking harmful chemicals into the soil. On the other hand, an atomic battery is designed to last up to 50 years without needing a recharge. Imagine the reduction in waste if we didn't need to replace our batteries for half a century. But what happens after 50 years, you might ask? Well, the atomic battery's nuclear material decays into a stable, non-radioactive element. This means that, unlike nuclear power plants, atomic batteries do not produce long-lived radioactive waste. Of course, this doesn't mean atomic batteries are perfect. There are still many questions to be answered and tests to be conducted. There's the issue of what to do with the battery once its energy finally runs out. And there's the question of manufacturing. Can atomic batteries be produced on a large scale without causing environmental harm? While it's clear that more research and testing are needed, the atomic battery could revolutionize our relationship with technology and the environment. We live in exciting times, and it's fascinating to see where these developments might lead us. So what could the world look like with atomic batteries? Imagine a world where your gadgets never run out of power, where your phone is always ready for that crucial call, where drones can fly indefinitely, facilitating a whole new level of efficiency in industries such as delivery services, agriculture, and surveillance. This isn't just a pipe dream. The atomic battery, a prototype smaller than a coin, has the potential to supply power to a vast array of smaller devices for up to 50 years without recharging. We're talking about a future where the phrase low battery could become obsolete, a future where the constant search for a power outlet could become a thing of the past. But it's not just about convenience. This technology could lead to significant environmental benefits by reducing the need for constant production and disposal of traditional batteries. The atomic battery isn't just a piece of technology, it's a glimpse into a future where energy is abundant, reliable, and sustainable.